Hi, my name is Frank, and I'm the Director of Product for Code Security here at Checkmarx. And today, I'm excited to walk folks through a new feature that we've developed. Historically, static code scanning, or SAST, has leveraged queries in order to scan code. This has meant that anytime a new language or a new vulnerability needs to be scanned, a query has to be added, and code has to be searched with that query in order to identify the vulnerability. This has meant that supporting new kinds of threats, as well as new languages, has been time-consuming. However, in a world with LLMs capable of generating exploits in minutes, that delay in support is no longer acceptable for our customers. That's why we've been working on a new agentic code scanner, or AI SAST, that leverages LLMs in order to scan languages and detect vulnerabilities that weren't previously supported. Today, I'm going to walk folks through how this new scanner works and walk through a couple of vulnerabilities it's detected in some Gosu code that I've uploaded to Checkmarx. As you can see on the screen, there's a project called Gosu demo that's been created that has 25 vulnerabilities in it. In order to scan code, a customer would navigate to the scan button, click it, and then choose to upload code. I've already uploaded a zip file that contains a Gosu vibe-coded application for an insurance application company that looks at insurance applications and processes them. What I'll do next is I'll walk through some of the vulnerabilities that this scan has generated. By clicking on results and clicking on SAST, I can see all of the vulnerabilities that have been detected. What's important to note here is that this new agentic scanner works within Checkmarx's underlying SAST engine. And what that means is, regardless of what language exists within your code base, we'll test it. In this case, we're looking at Gosu first. However, we can see that it has also identified any number of additional vulnerabilities. If this code had, for example, Java or Python or any other kind of language, they would also appear here as part of vulnerabilities, serviced in the same view. Let's quickly look at some of the vulnerabilities that have been detected, and I can show you how Checkmarx SAST has been able to highlight these in a new supported language, Gosu. To start with, we can see the most critical vulnerability is use of hard-coded credentials. If you click on View, we're able to show you exactly where these hard-coded credentials are within the application and provide a best fix location. This can be done for any vulnerability that is shown. Next, we can see that there are some SQL injection-based vulnerabilities that are identified. Similar to previously, we can use these vulnerabilities and see the attack path that exists, highlighting exactly how this vulnerability was identified, and again see the best fix location if someone wanted to adjust it. Similar to how other scanners work within Checkmarx and how SAST works, all these vulnerabilities can be edited with triage statuses, severities, and notes added, just like any other language that Checkmarx supports. Walking through some additional findings, we can see that there are use of broken or risky cryptographic algorithms, CSRF forgeries, and a variety of medium severity findings as well that have been identified. In each of these cases, users are able to view findings, interact with them, triage them, and solve them for customers. In this case, this scan took about 7 minutes to run and is considered a medium-sized Gosu application. However, we can support any number of sized files, applications, and they can be triggered either by uploading a zip file, as I demonstrated, or connecting directly to your GitHub repository. Thank you for watching this demo, and if you have any questions, please feel free to let me know.